Welcome to an impromptu session of Emerald Hill Skies. My name's Doug, and we're coming to you tonight from the outskirts of Louisville, Kentucky, where Louisville, the city, has put on a big celebration today that includes fireworks and a big air show, a big drone show tonight. It's been a pretty big deal. But I was walking out of the house tonight with the dog and just realized, oh my goodness, it's so clear. Surely we can sneak away and just do an hour of EAA, Electronically-assisted Astronomy. And we're glad you're here. We are working off of a RASA 11-inch scope tonight. It's on top of that Pier-Tech Adjustable-Height pier that you see there just to the side here on the screen. And it's inside of a Pier-Tech Tele-Station 2 observatory, about 200 feet away outside. And I'm in the nice office here away from all the mosquitoes or whatever. It's actually a really nice night out there tonight. It's 71 degrees. I can't get used to these balmy temperatures, but we're really happy to have you. The sky is pretty bright tonight. I don't know if it's all those people that have been out there looking at those fireworks or not. This is a live view of the sky atop the telescope. It's a ZWO ASI2600MC monochrome camera that's just got that 150-degree wide view lens of the sky, and it's giving you kind of a connection to the sky there. I'm just going to check my audio. Looks like everything's going there. We mentioned that we're working off of a RASA 11 telescope. It's on top of an iOptron SIM. That's a CEM 70G mount. And we've got on top of the scope a little outrigger, an equipment plate. And in that equipment plate, you can see that ASI178 monochrome camera, along with a Pegasus Astro Powerbox Micro, distributing power to the stuff that's on the scope there, and a Pegasus Astro USB hub that's powered and gathering up the data from the two cameras. The other camera I might mention is a ASI 2600MC Pro, a one-shot color cooled camera, and it's mounted there at the front of the RASA 11 corrector plate, and that's the dew shield around it. At the base of the scope, there's a little rig rack, you might as well call it, and it's got the power distribution center, the 12-volt power adapter, the 12-volt power distribution center, and the little device up there on top that converts the data from the scope into the kind of signals that we can send over fiber optic cable. And it sends it inside the office here where we're observing tonight. So let's go look at the scope, and we actually have on our screen here Caldwell 54 already stacking here. Caldwell 54 is also known as NGC 2506. It's an open cluster, and it's in the southwest part of the sky. If you'd like to look at our Planetarium software here on the right, you can see that we're looking down here at the bottom. There's a cardinal point southwest. You can see we're looking at the southwest part of the sky, and as we kind of zoom in, you can see that this is a very rich star field, and then on top of that very rich star field is this open cluster. And I think Sir Patrick Caldwell Moore, he figured that we ought to list this open cluster in some catalog, and since it didn't make the Messier list, I think he felt like we ought to at least get it into this one. It is beautiful. It has quite a few different colored stars, a lot of these blue, bright, hot stars that are fairly new, along with several orange stars that are traveling along with this cluster. It's really beautiful. Now, on the right-hand side then of the screen, the part that's immediately adjacent to me here, you can see the Planetarium software. So that's showing you, it's Starry Night Pro, showing you sort of like a picture of what the night sky should look like. But this view here on the left side is the view from SharpCap, looking through our 2600MC Pro, and sure enough, there you see the very cluster that we're talking about. And let's take that deep sky image annotation off and just take a look at that cluster, and you can start seeing all the different colors of stars that are there. Lots of different oranges and yellows and whites showing up so far, and lots of little dots that are just barely discernible in this cluster, Caldwell 54. So we'll take a picture of this to save a snapshot so that we can remember it exactly as seen. We're going to go up here in our Planetarium software, and we're going to say add that to the Caldwell observed list. And this is the first time I've ever looked at this cluster, so we're going to do an observation here. And it's already figured out that our observing session should be listed here. We're just going to make sure we note that it is with the RASA 11, the 2600. It's the only scope I would ever be using. But I've just put here in the observing notes, we could see an astounding collection of various colored stars, blue, white, hot stars, along with red, orange, older stars. Beautiful sight. Rich star field. I think we're looking right into the Milky Way. I went over to Wikipedia and looked, and there's not a lot written about Caldwell 54. It just says it's a mildly elongated open cluster in Monoceros, and it's about 12,000 light years away, and sure enough, it's near the galactic anti-center. It was discovered by William Herschel in 1791, and it's about 10,000 light years from the center of the galaxy, about 1,600 light years above the galactic plane, intermediate age around 2 billion years, apparent years old, and has around 94 probable members. So not tons of stars in this, but pretty enough that it makes a great site for Caldwell 54. So let's go to our livesky.com, and we'll click on our observing list here, Caldwell working, and we'll edit it, and in our edit we'll search for 54 and then remove it from the working list. That way we'll know that we've observed it. So one last chance to see Caldwell 54. These open clusters always remind me of Christmas for some reason. Look at how many stars are in that frame. It's just a beautiful frame full of thousands of stars. Very rich star field. Let's save that one more time, exactly as seen, and then we'll go up to our sequencer and we'll switch over to next target. And let's go see Caldwell 31. And we'll center on that. Caldwell 31. You can see that it's running past the west and headed over into the northwest, right over the Louisville Light Dome. And that's what Caldwell 31 is supposed to look like in our rectangular field of view. You can see the telescope slewing there, the C31. It's just about 20 degrees above the horizon, so that's well down in the Louisville Light Dome. Caldwell 31 is also known as IC405. It's the Flaming Star Nebula. So we'll go down here to our title and we'll say Caldwell 31 is known as IC405. IC405. And this is a diffuse nebula, the Flaming Star. And we'll also go up here in our SharpCap title slide and change that to C31 as well. This nebula is so lost in our Louisville light pollution. I hope we can see it here. We'll just do another plate solve to make sure that we catch up our live view through our, that our mount is pointing at, and make sure we synchronize that with what our ASCOM bridge software wanted us to point at, be able to look at. And as you can see, it's solving that frame. What that means, it's looking at its collection of data. And by the way, it's just 48/100ths of a degree off. So now it's going to make that correction and insert a correction in its database so that it'll be that much closer the next time. And you can see this layer of light pollution. I suppose if we were using an eyepiece tonight, we were all out there at the telescope. Of course, we'd have to take turns one at a time looking through the eyepiece. And those of you that are watching via Zoom or watching the recording rather on YouTube, you wouldn't even be able to look through the eyepiece. But if you were here and could look through the eyepiece, you would notice all that light pollution. And I doubt that we'd be able to see anything of this nebula. We'll go ahead and start our sequencer to run the start imaging sequence that we have. It's a very simple sequence. It merely sets the exposure to 20 seconds per frame and the gain at 100, which is a really, it's a nice gain for this camera. It has a wide dynamic range. You could think of that in the old-fashioned world of film photography. You could say it has lots of f-stops, 14 or so different f-stops at this gain of 100. Because it's a different part of the night sky, we're going to do another color balance here, a white balance. You can see how that helps us get our different shades of colors aligned. Going to run our blacks there at the crest and then run our mids. Let's back off to see the whole field of view. Our mids around there. Yeah, it's going to be. Let's take a look at this. See if we can find this nebula. Look at this interesting little box formation here. 4 stars in a row on the bottom of the box. 4 stars on this side, and if you count that one, that's real dim. 4 stars, but at least 3 stars on that side. Let's take a look over in our Planetarium software, and let's see if we can find this box shape. Boy, I don't know if we're gonna be able to find that or not. I wonder if these 2 stars, oh, look at all these bright stars here. Not seeing that in our frame, are you? But it definitely says that our mount is pointed there. Not seeing any diffuse nebulae yet. Hope it's not because of all the light pollution. Let's go back and look at our whole frame. Make that just a little bit blacker. It is stacking frames okay. Let's look at the description of this. C31 is a diffuse nebula. That's about all it says. Let's go to the Hubble list of Caldwell Catalogue, and let's go to look at C31 here. Oh, it doesn't have it. Let's come out here to C31 Hubble. It doesn't have a view of C31. Well, let's just say C31 Flaming Star And let's look at some images of that. Wow, it certainly is beautiful, huh? Look at that. That would sure be a beautiful sight if we could see that, wouldn't it? Wow. Let's go to the wiki page on the C31 Flaming Star wiki. IC405, is that correct? Yes, IC405. And the emission and reflection nebula, the constellation Auriga, surrounding the bluish star AE Auriga, shines at a magnitude 6. Wow. I wonder if we're losing it in the light pollution tonight. Here is a wonderful collection of stars that we're not seeing. I wonder if these 4 stars could be those 4 in a row that we saw. And this could be the 4 that are the left side. Very likely is. So our nebula should be in the frame. Let's go back over. I wonder if it's starting to show up there. Just barely. Let's go ahead and back this off over there for a second. Just, I think it might. Right there. Let's pump up our mid some. Ah, there we go. Now we're starting to see some of the nebulosity. There's some right here, you see. Look at that nebulosity starting to form up. And then there's a little bit of nebulosity here as well. Boy, it's faint in the Louisville light pollution, isn't it? We really had to crank up these mids pretty high to be able to see that. But now you can start seeing it form up there, can't you? You know, I might mention, while that's live stacking for another moment, we've just been stacking for 5 minutes. I might mention that we've gone to a different audio solution, and I'd appreciate it when you listen to this, whether it's live or on YouTube, if you wouldn't mind saying something about the audio. What we're using now is what's called the DJI mic. And it comes in this nice case, sort of reminds you of the charging case for AirPods, doesn't it? And it has 2 microphones, so you can record 2 sources at once if you want. And I just have this receiver plugged right into my laptop. You can do that via the USB-C. And you can plug it right into your laptop that way, and that receiver becomes your audio processor. And then the microphone I have down here on my belt, it's very tiny, isn't it? DJI, there's the transmitter. And then I've just got a little Shure lavalier mic that goes with it. I'll be interested in knowing what you think of the audio. You know, I'd always been using one of those big mics in front of me, and the other day I just noticed that I was so tired of moving it back and forth. Just got tired of it being in front of my face. So I'm going to be eager to see what you think of this. If you're watching the live stream, by the way, if you wouldn't mind going ahead and telling us where you're observing from, that would be fun to kind of see where you're observing from. Right now we're looking at Caldwell 31. You can see that it is forming up here in our frame, and we've had to boost the, let's put our, I'm going to hold the shift key down, and that'll give me a little fine tuning on this dark line. I don't want to go so far that we lose that nebulosity, but I want to try to get rid of some of that Louisville light dome. We are running a filter tonight. It's the, I shouldn't say tonight, we always run the Celestron light pollution filters. The only way to live here in Louisville, light pollution. We're about Bortle 6 skies. Holding the shift key down as I slide these. That's 8 minutes, and you can already see quite a lot of this nebulosity for the Flaming Star Nebula. Now, we observed this back in 2021 on January 12th, and I said that night the nebula is hiding out. So I don't think we saw a lot of it. That was January 12th. We were still super new at observing. On December 1st, we did see a lot of it that night, but I bet there was less. I bet it was maybe not as deep in the western sky toward our light dome. But I wrote there a lot of hydrogen alpha showed up after just 5 minutes. And then December 3rd, 2021, amazing collection of gases, I wrote. So tonight we're going to say this object was only 18 degrees above the horizon, hanging well into the Louisville Light Dome. We were surprised we could see any nebulosity at all. But it still came through. Beautiful. These are hydrogen alpha clouds lit up by the nearby bright stars. Something like that. Okay. C31. Well, let's come back to it one more time. Let's make the sky just a little darker. I'll hold the shift key down and we'll move that black level over a little bit. Boy, it's very touchy. You start losing a lot of the object if you... We're at just 10 minutes. I think we'd have to hang out here quite a bit longer to see all of the nebulosity, but certainly you can start seeing wisps of it, and here's some more wispy, cloudy nature that's starting to show up. And lots of Louisville Light Dome also showing up. So once again, this is C31 now at just 17 degrees above the horizon. So let's save that just so we can remember how lost it was in Louisville Light Dome. And we'll switch over to next target mode. So that finishes C31. Let's go now and try C50. C50 is just 14 degrees above the horizon. It's a little more over toward the south. Oh, it's the Rosette Nebula. C50, let's slew there. And notice how we're swinging a little bit away from the light dome and headed over more toward the southwestern sky. This is also in the direction of the constellation Gemini and Monoceros, well down just right above the tree line of Emerald Hills, little 61-acre campus here on the southwest portion. Actually, I guess it's not so much in the southwest, it's more on the west, so we'll still see a bit of light dome there. And notice how we're right above the trees. Let's open up that info window for C50. We'll go over here, we'll put C50 in here in sharp cap and change our title down here to C50, also known as NGC 2244. I believe it's the Rosette Nebula. All right, we'll go back up here and switch back to auto. And wow, that's an ugly sky with all that light pollution, isn't it? Let's do a plate solve one more time just to make sure we're spot on. I think this is the cluster that lights up the middle of the Rosette Nebula. Looks like we're still somewhat above the trees. 0.33 degrees off we were, so it's going to make that correction. Yeah, that is indeed the cluster that lights up the Rosette Nebula. We'll just let the telescope settle for just one moment after it made that minor course adjustment, and now we'll start imaging. And you can tell that when we start imaging, we go back to that 20-second exposure. I wonder if we should do 30-second exposures tonight. We'll just look at the first frame or two and see what the Rosette Nebula looks like when it pops in here in a second. Again, if you're watching in the live stream and you wouldn't mind telling us where you're observing from, boy, the light pollution is alive and well tonight, isn't it? Okay, we'll move those mids over and bring the blacks up around top of that crest. Let's do increase this to 30 seconds. Yeah, that's the open cluster that's here. NGC 2244 is the open cluster, I believe. In fact, yeah, C50, it's described as an open cluster. NGC 2244, also known as the Rosette Nebula, is an emission nebula and an open cluster in the constellation Monoceros, located 5,000 light years away from the Sun. This open cluster is one of the finest in the sky, but the nebulosity involved in it is harder to see, requiring dark skies and a narrow band nebula filter. Portions of this large object have been given individual NGC numbers: 2237, 2238, 2239, and 2246. How about that? Here's 2252. Now this is a case in which Starry Night Pro did not come with an image of the Rosette Nebula. Let me just hop over here to the mode. I'm going to put in, let's see, images. Is that what I need to put in? Yeah. Notice how if you go to Starry Night, oh, I'm sorry, I don't have you on screen, do I? My apologies. Notice how if we put in images up here, we can search for some of the switches in Starry Night Pro. So in other words, the search box also shows us adjustments that we can make on the sky. Isn't that interesting? It's not only going to, like for instance in Sky Safari, or if you search for an object in practically any other planetarium software, you're always going to see objects over here, but Starry Night Pro shows you everything, including configuration switches. So I'm going to turn off user images, and you'll see what I mean here. When we turn off user images, this is the way Starry Night Pro came. And that image of the Rosette Nebula is so faint that we practically don't see it. So I actually came on a moonless night when the Rosette Nebula was high up in the sky, and I actually imaged it for 10 minutes or so. And then Starry Night Pro lets you mount that image in your night sky, in your planetarium software. And it becomes a permanent part of what you can observe in your planetarium software. Isn't that cool? So that my images become a part of the night sky in this application. I think that's so fun. And you can see it's a decent image, isn't it, in the planetarium software. Now let's come over to the real thing, and this is our live view. You can see what a mess that is, but it's because we're still trying to get used to all this light pollution. let's bring our black level over just to the right of that crest and bring our mids up. But boy, you know, there's no sense in zooming in much here because this is such a big target. This Rosette Nebula stretches like, I mean, a degree or so. We can let that image. Boy, you look at that and you think, well, my goodness, are we ever going to see anything here tonight? And I guess with all that Louisville light pollution, it doesn't look very good. But that's just 4 minutes. While that's collecting data, I might just say Sir Patrick Moore, he lived over in UK. Chelsea, I think, was the name of the town where he lived. And he was a modern day amateur astronomer. You know how Charles Messier lived in the 1700s? Well, Sir Patrick Caldwell Moore, it's kind of a compound last name, Sir Patrick Caldwell Moore lived in this recent epoch. He only just passed away in 2012. And in Stephen James O'Meara's book on the Caldwell objects, he tells quite a bit about Sir Patrick Moore and these 109 objects that make up the Caldwell list. He explains kind of how it came about, and then what he does is he actually includes a foreword from Sir Patrick Moore. And here's actually a picture of Sir Patrick Moore here. So you can see him there in his English attire. And Stephen James O'Meara asked Sir Patrick Moore to write the foreword to the book, and Sir Patrick Moore writes about the Messier list and how the Messier list was basically objects to avoid in the night sky because they were comet hunters. And then Sir Patrick Moore says, well, I couldn't really name this list the Moore list because then people would abbreviate it with an M. And that would be unfortunate because there already is an M list, the Messier list. So he actually used his compound name, and the other part of his compound name is Caldwell. He says in his foreword he's not really a very avid deep sky observer. Most of the time he observes, you know, the solar system. But at the same time, he did look at some of the objects that were missed in the Messier list, and he felt especially bad for those south of the equator because they weren't included in the Messier list at all. So he said, why not make a list of objects? And so the next morning he just sat down at his desk and he decided to list 109 objects, and he arranged them in order of declination, beginning in the far north and ending up in the far south. And that way, you know, they were a little more, I guess you could say, maybe intentional in their listing order, because Messier's list is basically the order that his friends and he discovered the objects, not really very orderly at all. He wanted these Caldwell objects to be visible in a 4-inch and larger telescope, whereas the Messier list, you can pretty much see a lot of those with your naked eye or with binoculars. He wanted to make the Caldwell list basically be a telescope list. And so he just made the list. I think he did it in one sitting. And he put it in an envelope and sent it off to Sky and Telescope. And he says he didn't give it any more thought until Sky and Telescope sent back the layout of their December '95 issue for him to take a second look at before he approved it. And he was just astonished that they had done a major spread on this So the December 1995 Sky and Telescope issue was the beginning of the Caldwell list. Kind of a modern list, isn't it? And within just a few months, clubs started looking at it, people started observing it, and finally Stephen James O'Meara, who is a famous naked eye observer and observer visually with a telescope, he wrote this book in his Deep Sky Companions list and made it even more famous, and also cleared up a couple of errors that, like in all lists, that are possible to find. Let's go back to our live screen view here, and you can see we've got 9 minutes on this. Let's see if 9 minutes has helped us at all. Not much. I'm going to come here, right about here. Let's back off to the full view. We're getting a lot of Louisville sky dome, aren't we? And this might even be a tree. I bet that is. That's the beginning of a tree. Wow. Yep, I'm afraid those are trees. Look, here's a tree here, and there's a space between trees. Rats. This object is just, let's go back to our list view here and go to the Caldwell working list and look at C50. Just at 12 degrees. Yep. I'm afraid we're losing this into the trees. So I'm just going to make it a log entry here. We lost the rosette into the trees. We'll have to come back to that. Another night. Look at the other objects as well. They're all going to be at 11 degrees and lower now. The ones that we have left, the ones that we haven't observed yet, are going to be at 11 degrees and lower. Look at our scope and the way it's just looking barely over the wall of the observatory there. Fortunately, it is able to get up above the wall, but this is some of our trees. Let's look at our sky cam, and sure enough, you can see, first of all, look at the Louisville light dome over in that area, and then look at all those trees there that are right around, sure enough, 12 and 11 degrees, sadly. And now C50 is vanishing. One last look here. Let's do another color balance. Pull these over. Bring up the mids as much as we can. You know, I wonder if we're starting to see a little bit of the brighter parts of the rosette right here. We might still make this object tonight. Let's pull this over a little. Yes. Look at that. Right, I'm going to hold my shift key down and move this while I have the shift key down so I can do a little more fine tuning right about there. How interesting is that? You know, we could also have some clouds over in the low west horizon, but I don't know if you can see it in the YouTube version or not, but look down here below all this bright cluster. This is this cluster, what was it? NGC 2244. This is NGC 2244, and then look how we're starting to see NGC 2238 here. Look at just starting to get that nebulosity, even with those clouds and this Louisville light dome. There's the sky cam. Here's our view through the telescope, you can watch the telescope, and there's the live view. Look at this red nebulosity here. It's not the best image of the Rosette Nebula, but it is starting to form up. And look up here, you can start to see some parts of the Rosette as well. Let's pull these mids down a little. No, pretty much lose it. I wonder if we're getting some clouds. Let's go back over to the sky cam. And let me just darken that a little bit. It's on gain 400. I'm going to put it on gain 300 for a minute. So you can still see that Louisville light dome. I don't see any kind of clouds over there. I think that's just all of the thunder over Louisville light dome. So let's go back to our ASI2600 and let's do one more color balance. Yes, now we're starting to see the Rosette better, aren't we? Look at that. Now hold that shift key down again. Papa Tech. Nice to have you on, Papa Tech. Yes. Hello, Dennis. Good to have you here as well. Thanks for stopping by. We're trying to pull out the Rosette Nebula. We are seeing a little bit of it. Right in here, you can start to see the way the reds are coming through. This is more minutes than I would have liked, but to try to pull it out of that light dome, I'm afraid this is what we had to do. Now you can see that nebulosity collecting. So this is the wonder of electronically assisted astronomy. If we had tried to look at this through an eyepiece, there would have been nothing at all visible except for that bright Louisville light dome. But by using EAA, look at the way we can start to pull out this red nebulosity. So let's save this as seen and glance over one more time in the image that we have. Wow, look at that. You know what it's doing in our Planetarium software? It's sinking behind the trees. And so our Planetarium software is starting to show you this effect of the nebulosity hiding behind the trees. And then look, I'm sorry, get you back. Sorry, here's the Planetarium software. It's showing you the effect of the nebulosity hiding behind the trees. Now, look in our real view, and there you see the nebulosity starting to hide behind the trees. Exactly what we're seeing in our Planetarium software. Yet, we can still make out that nebulosity through the wonders of EAA. Thanks, Dennis, for helping us. It's hard to keep all these scenes straight. So we'll save this maybe one more time just to remember what a battle this was. And in our sequencer, we'll turn back into next target. Now here under Caldwell 50, we want to say in our observation, after 15 minutes, we finally were able to draw the nebulosity out of the light, pollution, and trees. Not our best image, but still visible. Can you see the trees there working their way down on the left-hand side? Now that the scope is moving down the trees, let's do another altitude sort. And let's see, we already did C31, but I don't think we did C8 yet. It's at 13 degrees. Let's see if we can go there. C8, and we'll slew there. Oh boy, look where it's going. Right over in the light pollution again. Let's take a look at C8. It's an open cluster. I don't think I've ever observed C8 before. C8. Papa Tech says, I had a bunch of tree shots during the February marathon. C8. And it's also known as NGC 559, an open cluster. All right. So we're going to just live stack this just briefly, just to try to get rid of some of that light pollution. We'll also look over here in our night sky in our Planetarium software, and we'll zoom in on this open cluster. It's not a very tight open cluster, is it? Kind of a loose collection of stars. Tell you what I think we're going to do. We're going to go back to this live view and plate saw one more time. Make sure that we're looking at exactly the right target. Just don't want to mislead you. C8 is an open cluster, also known as a galactic cluster. Not a lot written about it there. I guess we've got to get tight. Looks like only 40 members or so. Yeah, we were half a degree off. That's why we weren't seeing it there in the center of our frame. So we'll get that corrected. Not a really tight populated cluster, but several blue, hot blue stars that are pretty new. NGC 559. Oh yeah, see it now. So now we'll go back and just image it for just a moment so we can zoom in. We're at 13 degrees above the horizon. Now, I know that astrophotographers would never image something that was just 13 degrees above the horizon, because I think most astrophotographers would start at 20 or 25 degrees, some even at 30, because you're looking through so much of the atmosphere. Let's do a color balance here, and then we'll bring our blacks over there and put them right at the top of that peak. Bring our mids in a little bit more, and that's the open cluster right there in the middle. You can see it's not a very tight cluster and not a lot of stars in it, just maybe 30 or 40 stars in this tight open cluster, C8. Sir Patrick was stretching us when he made this one of the 109 objects in the Caldwell list. It didn't look that populated to us. 40 or 50 members. But still pretty. go out here in the Hubble view. And look at C8 here. Well, they don't have a picture of it in Hubble. Let's go C8 NGC, what was it, 559. An open cluster and Caldwell object in the constellation Cassiopeia shines at magnitude plus 9.5. So would never be a naked eye object. The brighter the magnitude, the lower the number. The lower the number, the brighter the magnitude. So we can see our naked eye at about a 3 or 4 magnitude with light pollution like this, maybe 5 magnitude in dark, dark sky. And this is 9 plus 9.5. So not a lot written about it. Excuse me. But still a nice looking cluster and certainly should be on a list. Now we're seeing some of the granular stars that make up the greater portion of the Galactic Cluster, as the Wikipedia article called it. So we'll save this exactly as seen and stop live stacking. And you know, I think we're going to call it at that. I was out last night till something like, I don't know if it was 4 a.m. or 3 a.m. in last night's observing, but I just walked out tonight with the dog and realized it was so clear. So I just wanted to not give up this night. I see Papa Tech has said, good info and call, but why did he choose the ones he did? These open clusters seem everywhere. Why are they mentionable? I get that, you know. I think he wanted to find 109 objects. I mean, you know, there's no other way to put that. This cluster, you're right, it's not necessarily something that leaps out at you, even with an 11-inch telescope. It doesn't leap out at you, does it? But he wanted to give us, I think, a little bit of a challenge. You know, the Messier list has these huge Pleiades and Orion Nebula type objects in it. There are a couple of tough objects and a couple of binary stars, but for the most part, the Messier list tends to be naked eye or binocular objects. And I think Sir Patrick Moore, at his desk that morning in his handwriting, because he handwrote the original list, I think he just in one sitting chose these objects. It was probably from his observing notes, his observing journals, and he sent it into Sky and Telescope, not really knowing what they do with it. So it does contain things like the Rosette Nebula that are like those undiscovered treasures. I'm not sure that many people would have enjoyed C8, but I kind of liked it. I like seeing these kind of Christmassy looking clusters. But that's going to wrap us up for tonight. Papa Tech is saying, laugh out loud. You know, indeed. That's going to wrap us up for tonight. Thanks for joining us for this impromptu, unannounced, live, stream of electronically assisted astronomy from the outskirts of the Light Dome of Louisville, Kentucky, on a day when everybody celebrated with fireworks here, thunder over Louisville, they call it. Air show during the day, lots of different drones that were up in the sky tonight, 350 different drones, somebody said, that were making different shapes in the sky. And boy, we came out and saw shapes of stars and had to come here and do a little bit of observing with you. Thanks for joining us. I want to thank God for making these objects and for putting them up in the sky and for like pasting them there for us to see as the quiet stars, you know, rotate past us. The fact that he placed these objects for us to find, kind of like Easter eggs to discover, I really just tip my hat to him for making this such a beautiful place to live. I hope you have a great rest of your weekend. God bless you, and thanks for joining us here at Emerald Hill Skies. Good night, and God bless.